Willkommen, bienvenue, and welcome back to the modding of Isaac with Lyte. And today, we're gonna hijack the controls. That's right, we're gonna go in there, we're gonna steal the controls from the player and do something a little bit different with them. It's just gonna be a basic introduction to control hijacking and also tiny little introduction to the music manager. So let's get started and see what we've got. Gonna start a new run, as always. We're starting with PhD and an I'm confused pill. We made this pill just like we made the I'm angry, I'm always angry pill. But you'll notice that when I move around, a few things just pop up on the screen for debugging purposes. So when we go to the left, action 0 is true. When we go to the right, it's action 1, up is 2, down is 3. You don't need to memorize these, they're part of the enumerations. You don't need to worry. They're just here such that when I'm demonstrating it now, you can see which buttons I'm pressing. And then firing left, firing right, firing up, and firing down. Oddly enough, you'll see some extra actions over there on the right. Those are for working with the menu. When you're on the keyboard, use the arrow keys in the menu, which is your firing keys. But if I was using the controller, your movement keys are your menu keys, and it gets swapped around. So if you ever want to work with menu actions, it still knows what they are. So you can make your own in-game menu that reacts properly to the two different types of controllers. Now, if I press Q, I will use the I'm confused pill. Now watch carefully which actions I trigger. So now, I'm pressing left, pressing right, pressing up, pressing down, firing left, firing right, firing up, firing down. And the music is ever so wobbly now. And so, as you can tell, all of the controls are reversed until the music goes back to normal. Sorry about that. Once the music goes back to normal, the controls go back to normal as well. Left and right and up and down. So let's head over to the code, see how it works. I'm not going to show you how to make the pill. We've already done that in the I'm Always Angry episode. I'm not going to go into the pocketitems.xml. That's exactly the same as it was before. We'll do a little bit different things in the code, but I'll tell you that when we get there. In addition to registering the mod and then registering the game, yeah, I've got a fancy little thing now that highlights my cursor when I hit control. We also grab the music manager. So we make local music equals music manager with just empty parentheses. You can do the same thing with the sound effects manager, and so you can trigger vanilla music and sound effects from within your code. I'll look into whether or not you can add new sounds and music, but I make no guarantees on that just yet. Then we do the initial setup for our confusion pill. We get its ID number, same as always, get pill effect by name, I'm confused. Then we set its duration, how long we want it to last. I put it at 900 frames, that's about 30 seconds, but tune it to however you want it. And then end frame equals nil. So this is for once it's activated, knowing when it should finish. This epsilon is from previous attempts at the code, not necessary. Epsilons are usually just tiny numbers that are close enough to 0, but not exactly 0. But it's not important this time. Thank goodness. Then, on update, this is the standard passive effect update. So we grab the player, we look at the first frame. This is where you should add your pills to the pool for the run. If you add them when you activate the mod, then you start a run and it refreshes the pool and just jettisons your pill. So you get the color of your pill by adding the pill effect to the pool using your pill's ID number. Then it gives you the color back, and so then you can actually give your player your pill right here. We also initialize the end frame, just in case someone held R while they were confused. We don't want them to be confused for all time after that. We want it to reinitialize the confusion. As you can see, end frame is not totally capitalized. It will change. Duration and ID, on the other hand, are constant. I gave the character PhD just so that you could see that it was the I'm confused pill, and then we add the pill itself. Standard p-effect sort of stuff. First frame, good to go. When we proc the pill, so we have our confusion pill proc, we get the player in the pill effect, but we don't care about this pill effect because we set it in the callback. So the callback is use the pill, tell it to use the proc function, and it's just for our confusion pill. Gives us the player, which, oddly enough, we don't need either. You set the confusion pill end frame to be get frame count, so the current frame, plus your pill's duration. So we set the end frame, we will be confused until that frame comes. Got it? Super simple. Okay? Now, we've got a couple of extra fun things. Here, we're using a post update. It doesn't use the player. We don't need the player for this. So we're doing a normal post update here, no player information at all. So if the end frame is not nil, so we have set an end frame, and that end frame is greater than the current frame. You need to do this way, because nil is not greater than the current frame count. And you can't compare nil to a number. It just doesn't work. It's not 0. It's nothing. I know that's a weird semantic to get into, but there is a difference. So you check if it exists first, then you compare it. If it exists and it's in the future, then we mess with the music. So what we do is we take the music and cause a pitch slide. That's right, a pitch slide. What this takes is a float. Preferably a number between 0 and 1, but not really. A lot of times you think about the floats and you want the decimals, so you go 0 to 1, but for this, it's a pitch multiplier. I guess. I guess that's the best way of phrasing it. If you set it to 1, it's totally normal. You set it to 2, it's sped up. Roughly twice the speed, I would imagine. And then if you send it down towards 0, it's slowed down. Down to a crawl, down to not even playing. When you do a pitch slide, it's really a tempo slide too. That as it gets lower, it also gets slower, and when it gets faster, it gets higher pitched. Yeah, higher pitched is faster, lower pitched is slower. Just because it's mathematically a lot easier to do that than to try to keep the same tempo but change just the pitch. That is a nightmare. Speeding up is easy, slowing down is hard. And then I do a lot of math. I do love math. So I'm going to explain this math to you, such that you know exactly what it's going to do. So in the middle here, we get the frame count. So we look at what time it is, and then we do things to that time, because it's counting 1, 2, 3, 4, 5, 6, 7, which is generally good if you're working in degrees, but not so much in radians. And math.sine works in radians, not degrees. So you're accustomed to going 0 all the way back around to 360. Well, this math.sine is accustomed to going from 0 all the way around to 2 pi. So we need to convert our frames into something on the scale of radians. So we multiply it by pi and divide it by 90. You could divide it by 180, and then it's directly from degrees to radians. But it was doing it too slow for my liking. So by dividing it by 90, it speeds up the oscillations. And, oh, I didn't bother to explain to you why we're even using math.sine. Well, sine waves are nice, smooth waves. They start at 0. I don't have a really good way of drawing this for you, but they start at 0, they go up to 1, come back down to 0, go down to -1, and come back up to 0, and then they repeat over and over and over again. They're really nice because they start at 0. If you used cosine, it would start at 1, and then go to 0, and then -1, and back to 0, in the same shape that sine does. Oh, and then it goes back up to 1, because it always ends where it starts. So you get a nice smooth wave, no jarring edges, no points, no roughness. It's just a nice smooth oscillation back and forth. So what this does is it takes the current frame, converts it to a number of roughly a size we want to work with, and then sends it into math.sine, which turns it into a nice smooth wave over time. It starts at 0, goes up to 1, down to -1, back to 0. So that's all of this math sine business. You'll also use math.sine when trying to work out orbitals, if you're doing them without using the helper functions. Trigonometry is really handy for doing smooth movements in various types of spaces. So this is just a wave that goes up and down and up and down. Then we take the absolute value of that wave. So it'll start at 0, go nice and smooth up to 1, go down to 0, bounce sharply off of 0, back up to 1, and down to 0, sharply bounces up to 1 with a nice smooth arc up at 1, bounces off the ground, and it's like you would picture a basketball bouncing on the ground across the floor. Just instead of getting lower each time, it stays at the same height. So 0 to 1, 0 to 1. So that's going to make it slow, and then up to normal, and then slow and up to normal. And has that jarring effect down the bottom when it's really slow. Well, that's no good because we don't want it to just be normal and slow. So we multiply that wave by 2. So it starts at 0. So it starts really slow, goes to normal, then goes up to fast, and it smoothly transitions through fast, back to normal, down to slow, and you have that jarring change down at slow. So 0, up to 2, down to 0, up to 2, down to 0. So on and so forth for those 30 seconds. So that's what it's doing with this pitch slide. Slow, regular, fast, regular, slow. You can put all sorts of mathematical things in here. I just like sine waves because they have fun properties that you can modify like this to get smooth transitions or abrupt transitions. So this is what happens while you're confused. If you're not confused, you set the pitch slide back to 1, and then you set the end frame to 0. Now, I haven't tested whether or not this overrides things like GameKid, which makes it ultra fast, or if you have the broken stopwatch and it makes things fast or slow. I haven't checked whether or not this overrides that. So we might need a different way of resetting the music afterwards, because this should probably only run the once when transitioning from being confused to not being confused. So I think we should add something here. If confusion pill dot end frame is not equal to 0, then we do this and then we end. So we make this an else if, then we do this, then we set it to 0, and then we're done. So if confusion pill end frame is 0, and this, we do that. If it's just 0 but not that, we do this. If it is 0, we don't do anything. I think that's better. I like that better. So that's the pitch slide. But this music object has a lot of things that it can do. So let's just take a quick look at the documentation for the music manager. Shabam! So we can play, we can fade in, we can crossfade, we can cue more music, fade out, pause it, resume it, enabling the layer so it's more intense, disabling it so it's less intense. Here's the pitch slide. You can do volume slides to make it louder or softer. And yeah, so we can do a lot of fun things, but the music has to have an ID. So I'm not certain whether or not we can create custom music at this point. I'll let you know soon. So that's the music part. Now we need to hijack the controls. At the bottom here, I've just got the rendering such that I can show you which actions are being done. Here, we've got the fancy new callback. MC input action. So it's registering callback like we always did, but with MC input action. And then this is our function right here, on input, which gives you three things. The entity which the actions are attached to, an input hook, which tells you what type of input you're getting, whether it's a true, false, has it been triggered, is it being pressed, versus a continuous value where it's like you're pressing the stick on a controller. It could vary between 0 and 1. And then we get the button action. Which thing are we currently looking at? This callback is run a lot of times for a lot of combinations. And so you need to check whether or not you're in the one you're needing, and then you do the interesting stuff. So I'm going to walk you through what I've done here for the confusion item, then I'll head over to the documentation and we can look at some of the other extra things that you can do. If you want to see this in action in a much more interesting way, you might want to check out the Nuclear Throne Fish mod, where it's mouse-controlled firing. You attack with the left mouse button, and you roll with the right, because as we know, fish can roll. So here for confusion, we check if the entity is not equal to nil. There are times where the entity will be nil. It's not always associated with the player. When you pause it and go into the menu, it's not the player anymore. So if it's not nil, then our player is entity to player. It should always be that, but you never know with this game. So we get player, entity to player. Local confused is false. You start off not confused. But if the end frame is not nil and it's greater than the frame count, so the end of your confusion is in the future, then confused is true. So that's just initial setup. We make sure everything is set up the way we want. Then, if your player is in fact a player, that's what this does. If entity to player fails for some reason, this will be a nil value and this will come back as false. Should never happen, but it's good to check. And you're confused. And the hook is get action value. So input hook, there is an enumeration of input hooks. So if we head over to the documentation, input hook, action, is action pressed is Boolean, is action triggered also Boolean, get action value, that's a float. So what we're getting here are floats, numbers between 0 and 1 for particular action values. For particular action buttons. Button actions, can never remember which way it goes. So if we're getting a float, and we're confused, and we're a player, then you do these things. I know that's a lot of text crammed into a small space, but it's the same thing over and over again in slightly different situations. So if your action, the action that it told you you're doing, is action left. So the game is asking, do you want to go left? You return the action value of the player trying to go right. And then you tell it which controller to look at. So that's why we grab the player up top. Because movement and firing is attached to the player. So this entity is the player when it's looking for moving or shooting. So we turn it into an actual player, and then down here we get the controller index to know which controller belongs to which player. If that player is trying to go right, we apply that attempt to moving left. When you return values from this callback, it makes that the truth. about what was input. So you press right, you go left. Okay, so maybe we're not looking at should we go left. Now we're looking at should we go right. Well, we ask, is the player trying to go left? And return that value. And so on down the line. Move down, move up. It reverses those actions each time. Shoot right becomes shoot left becomes shoot right, down becomes up becomes down. Just a bunch of ifs and else ifs to remap the actual input from the controller into the type of input that you want. Now, the input object that we use here for input get action value has various other things that it can do. If we head back into the documentation, we were using get action value, which is perfectly fine for the movement and the shooting because it's a float. If you want to interact with dropping bombs or using pills or swapping the pills or the trinkets, that's where we use action pressed and action triggered. Because action triggered is a one-shot, boom, we've done it. Action pressed is through time. They're holding that button down. These buttons are a bit trickier because they're not necessarily mapped directly to the actions that you'd expect, so these aren't quite as useful, I don't think, at the moment. I'll explore them some more later. But then using the mouse, get the mouse position and get the mouse buttons that are pressed is really quite handy. If you want to make it more like Nuclear Throne or more like some of the other games where you have mouse control over all sorts of parts of the game, we have that ability. So if you want to make a minigame that uses the mouse, or if you want to change the way Isaac is controlled, if you want to change the way you interact with all sorts of things, you can use the mouse. But just remember, not everybody uses a mouse. You need to make sure that it's clear to everyone how your particular mod works. So that's input. And that's remapping our input. I have several ideas for what we can do with this sort of thing, but we'll have to see whether or not they turn out right in the end. But that's all I've got for this episode, because this last bit is just rendering that information to the screen. So whenever working with this stuff, make sure it stays intuitive for the player and always use enumerations, because putting numbers in here would be a nightmare. Use button action, dot action, shoot right, and things of that sort. It will help everyone immensely when looking at your code. That's all I've got for this episode. I will see you in the next episode of the Modding of Isaac with Lyte.